Hello, everyone, and welcome to our Fellows Public Talk presentations. I'm Claudia Rizzini, Executive Director of the Fellowship Program at the Harvard Radcliffe Institute. It is my pleasure to introduce our Hrdy Fellow Mauricio P. F. Fontes. In the world's largest tropical forest, where our eyes are drawn to the sumptuous greenery and vast biodiversity, Mauricio instead asks what lies beneath. Soil in the Amazon is a paradox. It sustains the lush rainforest, yet it is poor in nutrients and relies on fragile systems to conserve it. Mauricio is a professor at the Universidade Federal de Viçosa in Brazil, where his research focuses on the chemical and mineral compositions of Amazonian soil to assess the environmental risks posed by soil disruption and contamination. Over the last 40 years, more of the Amazon have been deforested than in the previous 450 years combined. Against the backdrop of rapidly changing landscape, Mauricio has mapped the variability in soil chemistry and the flow of heavy and rare earth mineral in soil, water, and plant systems across the Amazon. By looking at soil and water conditions over time, he has been able to track how toxic elements are stored in the ground and waterways, highlighting the increasing pressure of agriculture, mining, and urbanizations on the ecosystem. Mauricio's findings assist scientists and regulators in identifying elevated levels of pollutants and evaluating risks to human and environmental health. Deforestation and degradation have led the Amazon to a tipping point. While at Radcliffe, Mauricio is synthesizing existing studies and his work on soil health to develop a framework for sustainable and regenerative agriculture and land use in the region. The Q&A portion of the public talk today will be moderated by Hong Yang, 2022-2023 Radcliffe Fellow and Professor of Biological and Biomedical Sciences at Bryant University. And now please join me with a warm welcome of Mauricio Fontes.
Well, thank you, Claudia, for the nice introduction. And I would like to start thanking the Radcliffe Institute for granting me this fellowship, and also thanks to the wonderful staff that we have that make our lives easier and enjoyable in the daily basis. I also want to thank my wife, my partner of life, for supporting me all the time. And I would like to thank my RRP students, Carolina and Sky, for helping me in this research. And finally, to thank the fellows by this rich and diverse work environment and that we share in daily work at Byerly Hall and also in our activities. And we are going to talk today about the Amazon rainforest and its soils, the tipping point as an imminent risk of the savannization of the system. And I will make a introduction telling some things about Amazon in general. Then I will talk about the importance of this rainforest for the world, and then a little bit about Amazon soils and in this part I will talk a little bit in terms of general knowledge of soils, and then I will end up with the tipping point, several nuances that we have for this tipping point, and I will end with the final remarks. And to talk about Amazon is to talk about a vast region that has an amazing biome. And we can see that this biome is huge. It has 6.17 million of square kilometers. It encompasses 9 countries, and it is the largest rainforest in the whole world. So it's an environment that we should protect. And in terms of the Amazon formation, I think it's good that we have an idea what happened in terms of the formation of this part of the South America that is extremely important for the world today. And it all started with the uplift of the Andes Mountains. And we had this growing of the mountains, making the Amazon region as it is today. And then all the landscapes, all the ecosystems we have there started by the uplift of the Andes. And even today, the Andes is a barrier to the Pacific Ocean, and it affects the climate of South America, and by extension, the climate of the whole world. And we can see here that in the west part of South America, we have 2 tectonic plates, the Nazca plate and the South American plate, and they travel into each other. Each year, they travel 4, 5, 10 centimeters, and it happened for millions and millions of years, building up a huge stress in this part of the boundary, making friction. It's rock friction between 2 plates. And then, after some millions of years, the stress was released and the Andes grew. And in this growing, it shaped what is all this region in South America. And also talking about the Amazon formation, we can explain how it formed in 2 ways. We can have an easy, simple, and witty way to say it if we say it in terms of a storytelling. And then a storyteller would say something like that. Once upon a time, there was, in the west part of South America, there was a river, a big river called Nozama. And this river, it discharged, or it flowed in the direction of the Pacific Ocean. And then suddenly, a huge mountain grew in the coastline, and this river reversed the course, reversed the name, and now it's called Amazon River. And this Amazon River now flows to the west, to the east part, flows into the Atlantic Ocean in the other side of South America. That's one way to put it. And the other way is to see how it happened geologically. And geologically, we have more steps. Geologically, we start, if we look at the time here, from 65 to 33 million of years, and we can see that most of the rivers at that time would go into the Pacific or into the Caribbean Sea. Very few of them would go to the Atlantic. And when the Andes started to grow, we can see that the rivers started to change. And initially they changed, and they went all, or almost all of them, to discharge in the Caribbean Sea at first. Just a few were still going into the Atlantic Ocean. And then the Andes grew more. And with this growing, especially in the northern part of South America, it closed the door to the Caribbean Sea. And again, the rivers redirected, and now going more rivers into the river that was forming at that time. And more recently, less than 2.5 million of years, we have something like that. All the rivers or tributaries that come from the Andes and flowing together to make the Amazon, and the Amazon going to the Atlantic Ocean. And that's what made the Amazon River hydrographic basin. That's what we have today. And today we can see the Amazon River, the main one, but this Amazon River, extremely important today. It has like around 1,100 tributaries. It is the world's large drainage system. We have 6.15 million of kilometers that this hydrographic basin encompasses. And this stunning discharge rate, 175 millions of liters per second that goes into the Atlantic. And it has approximately 20% of the fresh water of the whole world. It's very important. And talking about the Amazon rainforest in terms of importance, I would like to call the attention to 2 points, extremely important: biodiversity and flying rivers. These 2 points are extremely important, and we can talk a little bit about them. For example, the biodiversity. There is no doubt when someone looks at a picture like that, amazing. We have here 4 different species of tanagers all in one branch. It's amazing. Arthur, with his experience in photography, would tell us how many hours this photographer must have waited there to get a picture like that. And maybe Adriana and the bird watchers fellows gang would be delighted with a scenario like that, no doubt. And if we talk about numbers, what can we find in a hectare of Amazon? 1 hectare for the Americans, it's approximately 12.5 acres. And in 1 hectare we can see bird species 160, and primates and amphibia, etc. and etc. It's amazing how the diversity is in there. And this diversity by numbers, we can have The first thing is that the Amazon hosts around 10% of the planet's biodiversity, and the numbers are really stunning, like plant species, fish, bird, amphibian, reptile, mammals, 20% of fauna species of the planet, 85% of fish species of South America. Only in Rio Negro, Negro River, we have 450 species cataloged up to now. And so, amazing numbers in terms of biodiversity. If anybody has interest, the sources are there. The other point, extremely important, especially in climate terms of the Amazon region, but also for almost all South America. That's the flying rivers. What are these flying rivers? Are massive masses of atmospheric vapor. They are vast, they are invisible, and they are a product of the condensation of oceans and the evaporation from the oceans and the evapotranspiration from the forests. And then a system like that, which is the system where we have the Amazon rainforest, we have here the ocean having all the water evaporated, sunlight going here, evaporates, and we have a lot more evaporation if we have a forest here. If we had, for example, a desert, it would be the opposite. More evaporation here and less evaporation in a desert, for example. So the winds would blow to the ocean. But when we have something like that, lower the pressure here, and then we have the winds blowing into the continent. And this wind blowing brings these aerial masses of humidity, making the flying rivers. Because we have here the concept of humidity biotic pump. And this humidity biotic pump is what makes the winds blow from the ocean and get together with the water that evaporates here and go further. And something also important, the path of these flying rivers, extremely important for almost the whole South America. And then we have here the sun and evaporating the oceans, evaporating in the rainforest, the wind blowing, and the wind blowing when it reaches the barrier of the Andes, it deflects, and it deflects down into the whole South America. It passes through Bolivia. It goes to the southeast and southern parts of Brazil, northern Argentina, Uruguay, Paraguay. They all get the benefits of the rain. And that's one point that we are going to talk later. If we have the Amazon region failing, everything else is going to fail. Exactly because we have a cascading effect of vegetation rainfall that sometimes it's put in a way that follows the path of the flying rivers. At first we would have something like that. The forest, each tree transpirating, the forest by itself evaporating and transpirating, making the evapotranspiration extremely important, and the moisture that comes from the ocean get together and goes to another place. Then one spot of the forest would help the other one and the other one, and so far, all the other ones. And then it's a virtuous cycle, no doubt. And that's what we want to preserve. On the other hand, if we have forest loss or deforestation, it would be the opposite. We would have, for example, a spot that we deforested, or that for something like drought or anything, the forest had a loss. And then we would have less moisture, and less moisture going to the other spot, that little by little all these spots are going to be affected. That's what we can call a vicious cycle, extremely dangerous in terms of the Amazon today, the cascading effect. So we can talk also a little bit about the Amazon vegetation. When we look at a picture like that, like taken from a plane or a drone or something like that, all we can see is this green and waters. I thought it would be the whole thing, something happened with this slide. And when we look something like that, we can see that we have a huge green tapestry or a green carpet. And sometimes when we go from someplace in Brazil to Manaus, the biggest city in the Amazonas state, or fly back from Manaus, we fly 3-4 hours just seeing that, just see something like that. It is really amazing. But it has also a series of other things to look after: forests, waters, trees. If Veronda was there, she would tell us the stories of these trees with the indigenous peoples, probably. And then we have lots of different vegetations and trees and waters. We are going to see that. It's very important also the way the waters are. And mainly we have dense vegetation, we have open canopy vegetation, we have clear waters, we have muddy waters, we have black waters, and that's what makes the beauty of the Amazon region. And talking about vegetation, we have to talk a little bit about soils. But I will start about soils first in general. And then in general, we have to put the importance of the soil. And then we have this phrase. It comes from the Soil Science Society of America in 2015. It was the International Year for Soil. And it says soils is the skin of the earth. It's capable of supporting life and is vital to life on earth. There's no doubt. If you take all the plants, all the animals, and if you take us, mankind, what do we need to survive? Food, clothing, shelter, water, and air. That's it. And the first three are provided by the soil. So there is no doubt. But I also like a phrase that I came up with after this many years, that life made soils happen. And from then on, soils make life possible. I think it says more. And if we recall a few weeks ago, David showed us and talked us in his talk about this impact crater origin of life hypothesis, sound and solid. But after that, I think the soils start to play. After the life originated, evolved, came to the continents, then I think the soils was a big part of this possibility that we have today for life. We can see that if we see a little bit, just briefly, about the soil formation. If we think in terms of the beginning of the planet, bare surface, only rocks, no doubt. And when we had the climate acting, breaking down everything to small pieces, then the right condition for the soil to develop started. And then we have the organisms populating the upper part. And then it makes the soil organic matter. And there is no soil if there is no organic matter, if there is no life. So life make the soils happen, no doubt. But the soils also evolve, they develop. And then today we can have a soil that's young, or we can have a mature soil, or you can have old soils. And I'm going to call the attention for the old soils because that's what we have most in the Amazon region. We have the old soils. But how we can know the age of a soil? It is pretty much of knowing our age. If we look at a baby, or a kid, or a youngster, or a mature man or woman, or an old woman or man, we can distinguish. We don't have to see their ID or birth certificate. We can distinguish the characteristics from a baby, youngster, and so on, from old man or woman. We can see the gray hairs, the wrinkles, sometimes the difficulty in motion. And we say, well, that's an old person. And the pedologist has to know how to recognize the wrinkles and the white or gray hairs of the soils. And that's what we do. And so we have the old soils as being major part of the Amazon soils. The Amazon soils, diversity. And then we have different soils starting from these ones. The soils that are impoverished, nutrient poor, clay rich, deeply weathered, highly leached, all technical terms to say they are old soils. And then we have several types of soils, yellow ones, red ones, with more organic matter in the surface, or not so many organic matter, different kinds of soils. But these kinds of soils are all very old soils. And very old soils meaning they are poor soils. But the point is that they support a lush, an exuberant rainforest, no doubt. And we have also, for the sake of contextualizing the soils for the end of the talk, we have also some soils with some kind of limiting condition. And these limiting conditions are, for example, if we look a little far to the soils, we don't see a lot, but when we get closer, we see that it has lots of stones. Stones made when the soils form. They are rich in iron oxides, and the wet and dry make real stones in it. And it's difficult to manage in terms of agriculture or conducting agriculture. And then we have also some layers of this material sometimes, what makes a soil with a strong limitation to agricultural use. And we have another type of soils important in terms of the Amazon region. They are not like, there's not a big deal, but enough to call our attention. They are the so-called white sand soils. They are almost only sand, extremely poor, very fragile ecosystem, but important in terms of having forest. Sometimes we have huge forest, like trees that are not only thin trees. We have this in these soils because the environment allows the forest to be there. And so if we keep the forest there, it's going to maintain. And these are the soils that we can see in different manners. In this case here, we have like almost a beach sand and some vegetation, but lots of them. In terms of this kind of soil, also a very fragile ecosystem that we have to preserve, no doubt. And also there is an interesting factor here about these sandy soils, is that sometimes there is a huge influence on the waters, the kind of river we have when we have this soil's influence. And the best example we have is here. We have here the Solimões River. That's the one of the two most important rivers in the Amazon region. We have there the Negro, and then we see that the Negro comes this way. The Solimões that gather all the affluents coming from the Andes, and they get together here, where the Manaus city was built. It was built very close to the encounter of the waters. And they make the Amazon River. Then Negro and Solimões. After the encounter, it's called Amazonas and go all the way to the Atlantic Ocean. And at this point, then there is this encounter of the waters. It's a beautiful touristic attraction to anybody that goes to Manaus. They go there to see that these waters, black waters from Negro, Black River, muddy waters from Solimões, they get together and travel for almost 6 miles without mixing the waters. It's amazing. It's amazing. Like lots of boats go there to see that because they are very different in terms of density of the water, in terms of velocity of the rivers, and they travel together, but they don't mix. That's the influence, because these muddy rivers are similar to the Solimões, which is enriched by the sediments from the Andes. So they are muddy, they are yellow, although they are called white rivers. I don't know why. But the Black River, the black from the organic matter, and the organic matter in soils that don't have the power to grab this organic matter. Not the clayey ones like the Solimões, but the sandy ones in the Rio Negro, Negro Black River, and the river similar to it. And now we start with the tipping point of the Amazon River. And this tipping point is good first to conceptualize. So it is the threshold beyond which global warming, deforestation, widespread use of fire, and clearing effects would become irreversible in terms of flipping the system from a forest system to a non-forest system. And all the studies that are coming now are increasingly showing that this tipping point of the Amazon rainforest is more probably within decades rather than centuries. In the past, all the papers and written Amazon papers would say, well, it's going to be in centuries. More and more, we are seeing that it's going to happen within decades. Some would even say years to have this reaching point reached. And we have some mechanisms and drivers. And the mechanisms and drivers, first of all, no doubt, is the global warming. The global warming, like burning of fossil fuels, deforestation, industrial processes that have all these gases in the atmosphere, the greenhouse effect, everything in terms of global warming, but mainly affecting the temperature and the rainfall of the Amazon region. First, the temperature in terms of a forest, because it decreases the productivity. Temperature rise really makes the forest lose productivity, and little by little we are going to have the temperature because it is not being kept below the 1.5 degrees that is considered a threshold. We are going to have the temperature affect in a big way the Amazon rainforest. We have also the temperature 1.5 is critical. And another thing is the rainfall. We have a given amount of rainfall that should have each year to avoid the forest or to make the forest stable. And then we have, for example, a critical rainfall threshold of 1,000 millimeters per year. If it doesn't rain this amount, the forest is unstable. If we have between 1,000 and 1,800 millimeters, we have the so-called bistable state. It means the forest sometimes, when it rains not much, it degrades. When it rains a little more, it recovers a little bit, but it doesn't recover the way it was before. And so it's going to be a degradation. That's the so-called bi-state. It goes alternatively from good to bad. And from that, we know that a safe boundary for having the forest stable, 1,800 or 1,800 millimeters of rainfall per year. And the mechanisms and drivers, the part of human, what we do in terms of the forest. And then we can have like the human impacting a lot, like deforestation, widespread use of fire, and economic pressure. The ones I thought were the most important ones. And like deforestation, no doubt, we have to try to stop the deforestation. The deforestation diminishes and causes the degradation. It causes forest fragmentation, what doesn't help in terms of keeping a forest stable. Widespread use of fire, no doubt. Fire drives degradation and accelerates the ecosystem collapse, no doubt. And also, the fire burning intensely can change forest into degraded savannas. Then another driver is extremely important. And the last one, the economic pressure that we have, agribusiness, no doubt, especially related to soybeans and beef, causing deforestation and degrading forests, expansion of roads, network dams, logging and mining. It tends to destroy the forests. And the consequences of reaching the point, we can see from two perspectives. From the soils perspective, we can have this impoverished and so on. They are 70% of our Amazon soils. Soils with some kind of limiting conditions, the one I told, 10 to 15% of our Amazon soils. And the outcome of the tipping point, degraded forest and mostly savannas, as the title of the talk says. And also we have the soils, almost only sand, 5 to 10% of our Amazon soils. And that's it, the outcome, very degraded forests and mostly desert. And from the global perspective, no doubt, biodiversity collapse. We have also the climate system impact and socioeconomic disruption. Going a little faster because my time is almost over, like biodiversity. From estimated 16,000 species of trees, 58% would be lost. Devastation of populations of animals, insects, microorganisms, critical ecosystem services like pollination and soil formation, everything would be compromised. And in terms of climate system, no doubt, the forest now acts mostly like a carbon sink, no doubt. And it would be reversed with the tipping point to carbon source. It would mean billions of CO2 being released in the atmosphere instead of being caught by the forest as it is mostly today. And the flying river system and all South America would be for sure disrupted in terms of rains in the southeast part of Brazil and in several countries. And the socioeconomic disruption, socioeconomic disruption, because we have lots of people there, 47 million people, including the indigenous people, communities, agricultural productivity decline across South America, no rain in most of South America, no productivity. And a few strategies that I think they are the best one to prevent. International collaboration to limit global warming, no doubt. Stop forest loss, such as deforestation, degradation, and fires. Government's political will in establishing protected areas, conservation areas, and so on. And support sustainable/regenerative agriculture implementation based on, among other things, the soil's vulnerability. That's what I am doing here now. And keep the Amazon rainforest standing. Lots of things to do without needing to cut the forest down. There is a social bioeconomy wanting to have good projects there. Some are in place, some are going on, but we need a lot more. and strengthen indigenous and local governance. No doubt, the indigenous people, the community people, they are who really knows the forest. They know how to take care of it. And then we have to strengthen their participation. And as final remarks, Harvard has been a powerful voice against the climate change and global warming through its institutes, centers, and departments, and its voice is heard worldwide. The Amazon rainforest system is crying out loud for help in trying to avoid this tipping point. And that's why I am profoundly thankful to Harvard Institute for Advanced Studies for granting me this fellowship that allows me to be one of the voices that support this cause. Thank you.
Wow, what a fascinating talk. Thank you for sharing your insights. I think the Amazon River, Amazon Basin has been on people's mind, scientists and general public alike. But I think very rarely we have an opportunity to hear someone who has been working for years and have the first-hand data to support ideas and perspectives. So thank you for the insights. Okay. Yeah. Now we take some questions from the audience. And as mentioned, for the audience here, you can use the Slido scanning. And for the online audience, please use the chat function on Zoom to submit your questions. So when we're waiting for the questions, I take the privilege as a moderator to ask my question, which has been burning in my mind during your talk. That has to do with the flying rivers, which is an interesting first time I heard of it. My question is, with the climate change, has been any updated data or observations on how the flying river has been changed in terms of the intensity or the patterns or pathways?
No, unfortunately, we don't have this. Like, we have the notion that it's important, and it's extremely important. There are a lot of studies trying to relate, like the deforestation, to this, but I don't think, at least I haven't seen any of hard data saying that, even because it's not something that is completely known, although it has, like the beginning of it, like 40 or 50 years ago, with a study that started to see that there was this pattern, and there is this pattern in other parts of the world, but definitely there is no data from this time and from now, at my knowledge, that we could see, well, is it already affecting? For sure, we have some indications, like we are having, from time to time, more droughts in the Amazon region, no doubt. And the rainy season that in most of places, the Amazon rainforest would be the rainy season 8-9 months. It is decreasing. And sometimes we have 6 months without rainfall in some regions. And I think that's an indication of the flying rivers being affected, of this cascading effect being course. But I haven't seen hard data about it.
It seems to it have a huge impact, not locally, but also beyond the Amazon Basin.
Yes.
For audience questions, How does the physical chemical degradation of the Amazon soils directly linked or impact on the value of agriculture? And can the agricultural leaders integrate scientific data to make decisions to prevent the further degradation of the forest?
Well, we have some studies. We don't have a lot of studies in terms of trying to map the soil vulnerabilities. That's what I think it would help. And as of today, we have had some localized studies in terms of soil fertility, in terms of heavy metals, in terms of rare earth elements, but all of them like separate studies. And we have had in the past good soil surveys in terms of mapping the Amazon soils in general terms. But what I think it's a lack lately is that we could have these surveys and research that would take the Amazon as a whole and not spots a very good survey that would take into account the vulnerability. Because I think that's the main point today, to localize, because the most of the soils, they are poor. We know that. They don't have lots of nutrients. We can supply them, but where exactly they are. And the bad ones, the ones with limiting condition, the ones like these white sand soils. We have some things written lately, but not a real survey, like a big project that would take care of this. Where and what are the vulnerability of the soils in terms of the whole Amazon basin? And in this point, maybe getting not only the Brazilian part, because for sure, Brazil has the largest share. Brazil has a little more than 60% of the whole Amazon rainforest. But there is also Venezuela and Peru and Bolivia try to work together in this kind of survey, especially in the vulnerability of the soils.
Another question related to the soils, that is, can you share a little bit more history and formation of the influence of the black earth, the black colored soil?
Okay.
And how the indigenous people dealt with this for years, and what wisdom that can we learn from them?
It's a very important type of soils. He asked about the black earth Amazonic or Amazon black earth soils. We call their terra preta de índio, because it's a kind of soils that we are finding in several parts of the Amazon. And it's really important in terms of giving us information about the past. Like the indigenous people there, they used to have these soils, and up to now, several studies, a lot of papers being published about them. But we don't know yet, was it made on purpose for a better agricultural use, or were them just a place that they would dump everything in terms of organic material? But the point is that these soils are extremely stable. They have a lot of organic matter, and a kind of organic matter that's not easily decomposed. So it remains. It has 1,000, 2,000 years there, and we go there now and see that they have all this organic matter, but there is also like ceramics and bones and everything in it. And so all this churning of this material, was it purposely made that way to have a better agriculture? Probably, but we don't know that for sure. But the point is, they have very good organic matter, what is called a recalcitrant, because it remains no matter what. And we see from managing normally agricultural soils, if we don't take care, the organic matter rapidly goes away. And that's the point for the most of the soils of the Amazon rainforest. The soil is there, rich in organic matter in the first centimeters, more rich in a layer like 10, 15, 20 centimeters above the soil, because that's the undecomposed organic matter. And then if you deforest, you are going to have, like, depending on the soil, 5, 10 years of using. The organic matter will go away. But if the forest is still there, even in the sandy soils, the forest is there, sometimes a good forest. In Brazil we call them campinas and campinaranas. The type of vegetation we have, it's a little different from a forest in a highland or even the floodplain of Amazonia. We have more denser forest. This forest that is called like the closed canopy. The sun doesn't go to the floor of the forest. In these campinas or campinaranas, we have an open canopy, and so the system is not that closed, but we have very good forest above a sandy soil. But take this forest out, no doubt it's going to be desert.
Yeah. As we only have a few minutes left,
Okay.
I will combine a few questions that has to do with the tipping point.
Okay.
So obviously it's a very important topic, and the Amazon River is one of the climate tipping element, as you mentioned. An audience asked, as a non-expert, he's curious about, wonder how scientists think about how close are we for the Amazon River or the basin to reach to the tipping point.
Yeah, it's debatable, because I have friends that work with that, and some of them would say, well, it's a matter of years. And some papers we read, it says more like, as I stated in the beginning, it's more something like decades, but it's going to be reached if we don't do anything now. And some are just skeptical. They say, wow, that's invention. Then these are the negationists, but they are even science. And they say, no worry, it's just normal evolution. Like the world is evolving, so more carbon has to go to the atmosphere, so and so. So there is no problem. But I think most of the people think that if we go in the pace we are going now, in terms of burning fossil fuels, industries sending lots of fluorinated material to the atmosphere, we are going to reach it in decades, like 1 or 2 decades probably, because it's the way we are going. And for sure, it would be a very big loss for the world in general, no doubt.
I want to end our session on a high note, maybe a hopeful note. Okay. That is, one of the audience asked, can you share one of the greatest successful stories that you think in the Amazon basin, or you have witnessed?
Well, lately it's hard to share like very good news, very good things in terms of, well, we are going in the right direction. But one thing I'm sure is that from the last government we had in Brazil, from this one, we had a lot of changes in good terms. So I could answer, yes, we have had a very good thing, because in the last government we had, most of the people there were these that, oh, don't worry about global warming, don't worry about this and that. And then we have a government that cares for that, although it also has its limitations in some points in terms of how to deal with the Amazon. But for example, to give an idea, we have an institute there called the IBAMA, Institute for taking care of the forest. And it was almost decimated in the last government. And now it's going back. Now I got some good news from my department that they are working together with the department, trying to put all these concerns in light again, because in the last government they were in the dark. And now that's a good news that I would share, is that we have more than universities trying to take care, but also government entities that are trying to get back in what I would call a right track in terms of managing the Amazon rainforest.
Yeah. That's great.
Okay.
Well, it has been a fascinating and engaging conversation, and thank you, Mauricio, for such a wonderful talk. Okay. And also I want to thank the audience, both here and also online, for their thoughtful questions. And you can always find out the Radcliffe program online, and the site is radcliffe.harvard.edu. So thank you for joining us today, and have a wonderful day.